Yeah, this will be a talk about the future of JavaScript. My name is Andrew Korlick. I am a JavaScript developer on Mike Hall's team that's telephony admin of BeerCloud. I love going to hackathons. I'm a tech evangelist, which you might be able to tell from me doing a talk like this. I'm one of the runners of the Angular full stack generator. It's an open source generator for generating a full stack web application built around Angular, and our most popular configuration is the mean stack. I'm also an amateur photographer and a rock climber. So this is meant to be kind of like a very top-down view of what ECMAScript is and the new specifications. So I'm going to try to keep it pretty short and not dive too deep into everything. So ECMAScript is the underlying specification of JavaScript developed under ECMA International. They are a standards body. ECMAScript 2015 is the most recently ratified specification. That's the official name for it, but we'll just call it ES.Next for short. And ES7 is the next specification that is currently in development. So let's dive in. There's two new keywords here for declaring variables. There's let and const. Let is pretty much the same thing as var, except it is block scoped and not function scoped. So in this if true statement, I declare a variable var1 equal to 1, and I let var2 equal 1. If I console.log var1, it'll show up, but if I try to log var2, I'll get a reference error because it's block scoped and not function scoped. And then const will act as you would expect. If you try to assign something to a const, you'll get an error. And one thing to note about let and const is they're not hoisted like standard vars are in JavaScript. So as you can see in this first console.log, we'll get a reference error for x because we declare x after it as being 1. But then in the console.log after it, we get a 1. And the section before we declare let x equals 1 is called the temporal dead zone. It's not fully supported by a lot of the transpilers yet, but yeah. A lot of people that are used to pretty much any other object-oriented programming language will be happy that classes are in JavaScript. And it pretty much acts like you would expect. You declare a class foo, you can extend it from bar. There's a constructor, supercall, getters, setters, static functions, which would pretty much in JavaScript be the same as placing it on a prototype object. Do note that classes are also not hoisted, so if I tried to console.log a new foo before foo is declared, I would also get a reference error. And in ECMAScript 7, there are property declarations and decorators, which Java developers would recognize as the read-only and the enumerable false at the end there. Decorators make it possible to annotate and modify classes and properties at design time. Super helpful. Arrow functions are one of my favorite new ones in ES6. So say if this is ES5 code, I'm making an array and I'm trying to filter out all of the non-integers.
So pause for a second. You know, it's really hard to see your screen, but you're doing a browser share session, and a lot of people have laptops here. Would that help you?
It's hard to see it.
It's just hard to see because the contrast is low and your colors, and then coming through on the projector, that's kind of tough for us to see.
Okay.
But we're going to go to the URL and follow along. Do you think that you want to try it? Sanders? You go to andrewkorlick.com, port 7000.
Yeah, and the slides should be updating as I'm going through them too.
That better? Yeah.
All right, go ahead.
Are you guys good on that side?
Yep.
Yeah.
Okay. So here we're back at the arrow function section, And so I'm filtering this array and filtering out all of the non-integers, and I'll get 1, 2, 3. What this would look like with an arrow function is in the filter callback, I would specify my argument as num. I would do a fat arrow, and then it would return number.isInteger num, and this would produce the same thing. And then I can also give an arrow function no parameters, multiple parameters, and then they can be multi-line with the mustache bars. Here's another good implementation of arrow functions. So I have this new class animal, constructing it with a type, and it has a say method where after a time of 500 milliseconds, I'm having it say something. So I'm going to make a new dog animal, and I'm going to tell the dog to say woof. But oops, undefined says woof. That's because in that set timeout, the this.type is a different this binding than in the class, because functions have a different this than their enclosing function scopes. So how would we fix this? In ES5 code, we would either bind the function to the this arg, or we would make a self variable and then just reference self instead of this inside the timeout. But with an arrow function, we don't have to do any of that, because arrow functions have the same lexical this as the enclosing function scope. So it would still say dog says woof with this arrow function using this. Another cool thing is template strings. So say I want to have a list of things in ES5 code, and I want to list them with new lines. So I would make an array of things, I would join it with new lines, and log it out, and I'd get thing 1, 2, 3. Or say that I want to log out, I have a, and then whatever pet is set to, I would just concatenate the I have a string with my pet variable evaluated. But using template strings in ES6, using this backtick character, it supports strings with new lines, so we would get the same output, thing 1, 2, 3 on new lines. And then there's also this, in the console.log here, we're using backticks instead of single quotes. So I would say I have a, and then this dollar mustache's pet, and it evaluates whatever is inside those mustache brackets. So it evaluate pet to be cat. I have a cat. There's a few enhancements to object literals. You can access the direct prototype assignment through _proto_. If you had say you had a handler variable declared before this object, instead of saying handler : handler, you can just attach it to this object by saying handler. You also don't have to do the same thing with declaring a new method. You wouldn't have to say toString : function. You can just declare the toString, and then you can also use the super declaration inside of it. So in here we're calling super.toString, which the super would just be the plain old object. So whenever we would print out this object, it would say thing : and then it would do the standard object toString. And lastly is dynamic or computed properties. So inside of these brackets on the last property, anything inside of it gets evaluated. So here we have prop underscore, and then we're concatenating it with this invoked function. And the function just returns 42, and we immediately invoke it. So this would be the same as saying prop underscore 42 : 42. Destructuring is another nifty one for ES6. Say we have let a, comma, blank, comma, b equal, and then array 1, 2, 3. That would be the same as setting a to be the first object in the array, and then b to being the third one in there. And there's the same thing with objects. We can say let object, and then we have a as 1, b as 2. and let A, comma B in an object equal object, and that will also assign 1 and 2 to be B. This can also be used inside of a function parameter position. So say we have a function func, and we want to take in an object, but we really only want to pull the name parameter out of there. So we say name colon, and then we give it a variable, x, and then we just want to console.log it. So when I call function x, and I give it a new object with a name of 5, it will just log out 5. One thing also to note is that destructuring is fail-soft. So say I'm trying to destructure A with this empty array, it won't throw, it'll just give us undefined. And you can also have a default for if the right side of the assignment evaluates to nothing, then we can have a default instead of it being undefined. And so the first new one there is defaults. We can also do this in strings, or in functions. We can say x and then y equals 2, and then z equals the invocation of this function. And those will be the defaults if we don't pass anything in those positions for this function. So f3 will default, y will default to 12, z will default to 3, and we'll get 18. There's also the rest parameter. Say I have a function x and then ... y. Y will be any of the rest of the parameters that are passed into that function as an array. So when I call f3, hello, true, y will be an array containing hello and true with a length of 2. And this can also be done on the other end with the spread operator. So say I want to call a function with x, y, z parameters, but I want to call it with an array. I can just call ... and then pass in the array, and it would be the same as saying function array 0, array 1, array 2, and we'll get the same thing. ES.7 has a proposal for rest and spread using objects, as you can see on the bottom. I'm not going to dive too deep into that one. Another one of the huge ones for ECMAScript 6 is generator functions. A generator function is a function that returns more than one value. So we have this function star counted 3. We're starting with an index, and while index is less than 3, we're going to yield index and increment it. And then we set this counter to be an invocation of count to 3. And then we console.log counter.next, and it will spit back a tuple with a value of 1 and a done of false. We do it again, index will be incremented. We do it again, it'll be incremented. We finally do it, it'll return done true. There's also yield star, which in conjunction with another generator, it will yield everything inside the called generator function. So say instead of counting to 3, I also want to count from 0 to 4. So in this new 0 to 4 function, I will yield 0, then I would yield to all the yields inside of my count to 3 generator function, and then lastly I would yield 4. And using our new for of loop for iterators, we can log out each of the iterations of this 0 to 4, and it will give us 0, 1, 2, 3, 4. ES7 has a proposal for async functions, which if you're a C# developer, you might notice, you might be familiar with this. It's basically functions returning promises. So in ES5 or 6 code, here's how we would make an async function. We would return a new promise, and then inside of that promise, we would either call the resolve or the reject function. In ES7, this would be the same as declaring the function with the async keyword and either returning or throwing. There's also a proposal for the async await syntax. So say we have a very similar async function foo, and we set a random timeout to just return the variable that was passed into the function. And we have another function, an async function bar, where we want to let x equal the result of foo, and we await foo. So the function will wait there for the promise to either get resolved or rejected from the foo function. Then after that, once x is set to foo or the function throws, we will return await foo again, and we'll wait for the other random timeout, and it'll be x plus 4. So assuming it doesn't throw, which it shouldn't, this will eventually, after the random timeouts, output 7. And the purpose of this is to make asynchronous code look a lot more like synchronous code. It makes it a lot more easier to understand. One thing that pretty much all async JavaScript developers are familiar with is a library like Q or Bluebird. ES.Next includes, out of the box, a promise library, which if you look at this, it's the same syntax as any promise library you're used to. Symbols are a new unique one for JavaScript. A symbol is unique and immutable data type and may be used as an identifier for object properties. So in ES.Next there is a new symbol primitive data type, and there's also a globally available symbol implicit object wrapper for the symbol data type. Well-known symbols are iterators, has instance, toPrimitive. It's like named enumerations in C, if you want to compare it to that. And also to note is, at the bottom example, if I make a new symbol foo and try to compare it to another new symbol foo, they won't be the same. It makes a new reference each time. Proxies. Proxies are used to define custom behavior for fundamental operations. All the fundamental operations of programming language like property lookup, assignment, enumeration, function invocation. So in this code, I'm making a new validator object, and with the set, I'm having it run a function. I'm given the object, the property, and the value. And if the property is age, and if the value is not an integer, I'm going to throw. And if the value is greater than 200, I'm going to throw. If not, I'm going to set the property on the object as you would normally expect. So here I'm going to let person be a new proxy of just an empty object, and I'm going to pass it in the validator. And I set person.age to be 21. It works. I console.log person.age gives me 21 as I would expect. But if I try to pass it in a string, it'll throw an exception. And if I try to assign it 300, it'll throw an exception that is greater than 200. There's a very wide possibilities of what you could use for proxies. ES.Next introduces its own module syntax, which I'm sure every JS developer is familiar with: require.js, common.js, browserify, all those things. But there's a new common way of doing it. So say I'm making this lib math.js. I'll simply just export a function sum, and I'll export a variable pi. Then in my app.js, I can import everything from the math lib as math. And in this console.log, I'll try to compute 2pi. I'll use math.sum, and then I'll give it 2 math.pi's, and it will work as expected. We can also kind of customize what we're getting from this library. So I could import pi as pi, PIE, and then just also pull down the sum. And using a very similar syntax, 2pi equals sum pi pi, we'll get the same result. Maps and sets are new data types for ES.Next. They are efficient data structures for common algorithms. So a set is a collection of distinct objects. Say I make a new set, and I try to add hello, goodbye, hello. It'll have a size of 2 because it ignores my second hello. And set.hasHello will be true. With a map, say I make a new map and I set, it's a key value storage, so I set hello to be 42, and then I can also use my previously made set as a key and give it 34. and when I get my set, it'll give me 34. Also to note is when you iterate over a set or a map, they're iterated in insertion order, not in alphabetical order or numerical order. So in this for item of map, we're just going to log it out. In my map, I have that first hello that I declared of 42, and then I have my set that I made earlier, and that's assigned to 34. Also to note are weak maps and weak sets. They're the same thing, pretty much the same thing as maps and sets, except they're not prevented from being garbage collected. So if you can use them for a volatile environment, it'll prevent a lot of memory leaks. Since they're so volatile, they don't allow iteration or looping, and you can't clear them for security. Also to note is weak sets can only be sets of objects. There's a bunch of new things for the number, math, string, and object libraries. A bunch of useful stuff that'll help you write less code. I'm not going to dive too deep into that. And then there's also implicit use of binary and octal literals. So as you can see, I'm making a new binary of 503 and an octal of 503, and they're all the same. Here's some other ES7 goodies that are in the proposal stage. There's an exponentiation operator. So this first line, 2 star star 3, means 2 to the power of 3, which will give us 8. And I can also say let A equals 2, A star star equals 3, and that'll be the same as saying assign A to be A to the power of 3. ES7 has a draft spec for allowing trailing commas, which it's not actually allowed in JavaScript right now, but it won't throw you a syntax error. But if you've used a language like Python, D, or Hack, they all have a specification for allowing trailing commas. And the reason for this is, say you have a function with a bunch of parameters, and you want to add a new parameter. In your source control, if you add a new parameter and you have to add a comma to the previous one, it'll mess up all of your history. So here, you just have to add a new line. You don't have to modify the previous line for a comma. There's a new function bind syntax, the double colon, which this document line will look a lot like jQuery code, but it's plain ES7 code. It will bind it'll bind the function to the right of it to whatever object is to the left of it. And if there's no object to the left of it, it will bind it to itself. Here's an example of an array comprehension. It's pretty self-explanatory. You just you set an array and you give it an iterator instead of the actual values. And lastly is object.observe. So say I make a new object, foobar, and I say object.observe my object, and on each change I want to log out the changes. So if I make a new property, Baz on object, and set it to 2, I'll get a notification that I made a add change. It'll give me the object, and it'll give me the name of the property that I added. Similarly with changing, I'll get an update, deleting, and a few other things. You'll get notifications for all of that stuff, and it'll help all of that with data binding. Alright, so now I'm going to talk a bit about transpilers. If you don't know, a transpiler is a type of compiler that takes a source code from one language and transpiles it to the source of another language, or compiles it to another language. And the 3 most popular ones that have implemented ES6 features are Babel, TypeScript, and Tracer. I'm a huge fan of Babel. It coincidentally has 71% ES6 and ES7 compatibility. It uses Facebook's regenerator transformer for generator functions. It uses the core.js polyfill for almost all of its ES6 and ES7 polyfills. And it has a big list of custom plugins and transformers for doing a lot of awesome custom things with the transpiler. Babel also has support for React and JSX, so that you can paste in your JSX code in JavaScript like this, and it'll output the React.create element syntax. TypeScript, it's a language written by Microsoft, and the main purpose of it is to be optionally typed to prevent errors during code writing. And it's got 25% ES6 compatibility. And the third one to note is Tracer. It's written by Google. It's got 58% ES6 compatibility and 14% ES7 compatibility. And thanks to Chris Hemp, he noted to me that we're using Tracer at Interactive for our onboarding service. We're using Babel for billing, WebAuth, and Web Directory, and we're using TypeScript for bridge services. So if you ever have any more questions about those specific transpilers, you should ask those teams. All right, here's some resources. These slides are on GitHub. I've got a link to the finalized ES 2015 spec and the ES7 proposals, and a link to a compatibility table that will compare all of the modern browsers, transpilers, and runtimes like Node.js, IO.js, all of those. All right, that's it. Are there any questions?
Those questions. Yeah, could you get that? You asked about the implementation timeline for ES7.
The idea is that it's going to go on a yearly release basis now. That's the idea with the ES 2015 spec. So the idea is that around this time next year, the ES 2016 spec or ES7 is going to be ratified.
I think that's it. I don't think there are any more questions, so I guess we can go ahead and wrap up.
All right. Thanks for coming, everyone.